it's okay. Right, let's open this bad boy up. Is it as weird as the watch? Who knows? Who knows? Got a bigger display on it though, for comparison. Big display. Lots of pins on this guy that all got bent about in the post. Right. There's our board. This one's got a lot of S&D stuff on it. So surface mount. And I haven't had a kit with surface mount stuff on it before. So this will be fairly interesting. I know how to do surface mount, but I've not built many kits with it. Okay, we got a beeper in this one. A little beeper speaker. I can go over there in the rubbish. There's our micro, which, okay, this is an STC11FO2E. Oh, it is different. It's the same brand micro, but it's a different model. Again, these are just generic programmable microcontrollers. So, right, and as you can see, in these little strips, here's a little strips of S&D components there that we got to solder in place. I think these are transistors. Styrofoam squeaking. I will try not to. And this dude is USB powered, so we've got a USB mini connector there as well, and a load of resistors. Right. Okay, let's have a look. So looks like I've got extra buttons for this. I see 2 buttons. Right, let's go in. We're going to be going in close for this one, and because I'm going to be using the hot air, I'm going to get my plate out. This is an old hard drive cover. Because it's metal, I can use this for I can use the hot air directly onto this thing without burning up my mat. So, right. Now I need to bring up my instructions for this. Yeah, we'll find out. I need to get... Oh god, all my magnets are sticking together. Oh, you know what? We're committed to that. Let's just put that mess to one side. Right, let me grab... I've got the instructions on my Google Drive for this. So that's what we're making, apparently. Right. Well, with the past first look at the final product samples, specific features are described below. Blah, blah, blah. Well, no nonsense. Begin making. Okay. Right. So there's our kit. Again, there's not much to this one because most of the passives are all S&D. Okay, right. First patch on the back of PCB soldering components to 120 ohms. 121 reads. Chip resistors 2. Right. Oh god. Okay, right. So I guess we're doing that row of resistors. So it said 121 reads, and I think that's what we got written on these guys. Let's go in for the super close up. Let me grab my work light for this one. I want some extra light. So let me just get this bad boy turned on. I don't use this light all the time because it's battery powered and only lasts for about an hour at a time. And I'll get that flickering under control, don't worry. Brightness. There we go. Okay, right. Now we've got a bit of extra light. Let's go in for the super close up. And that. Right, so we should find 121. And there's my finger for reference. That's how small we're working here. We're working really, really small. That's my little fingernail. So that's what we're soldering on this one. super small. And there's the tip of the soldering iron. So yeah, this one's going to be tough. This one is going to be tricky. Right, and I think I can afford a bit more brightness on this. If I just use my hands to kill the flicker now and then. There we go. Right, okay, so... no, that's going to be a problem. That's fine. Okay, right. So what happened to those guys? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's fine. Well, it said that these were the right ones, so let's get cracking. Time to clone his identity. Yeah, good luck with that. Yeah. You can't even use it to get into my phone because my phone does not have a thing. My phone does not have a fingerprint sensor. Right, I need the soldering iron on because I've got to prep the board. So what we're going to do, we're going to be using the pillow method here. I've got to bring this. I'm going to bring the camera right in for this one because we're working really small. Right, and I've got to put some. Got to put some little solder blobs along this board. Right, are we up to temperature? Yes, we are. Okay, here we go. So we're just going to solder blob all of these. And then, in order to get those tiny little components on, we're going to fire up the hot air gun. And let's flux that up. So I'm putting on flux here, and the flux is going to make all of this solder flow. It's going to make it all go super, super liquid and shiny. And make everything just sit in place. Right, now comes the tricky bit. Alright, so we need hot air on, 420, very low air. Right, let's do the first one. Oof. Right, we need a bit more air than that. There we go. That's our first one. Right, okay, that was nice and straightforward. These resistors are slightly undersized, so we'll now go ahead and flux capacitors are maximum, and we'll just put a load of these on. Okay. Need to be super careful not to actually lose all of these, because if I slip with this guy, it's all over. They have given me 2 spares though. Okay. Just pouring a load out onto the mat. And of course they're all upside down. It doesn't matter if they're upside down, but for tidiness, we'd like them to be the right way up. Oh, this is very small. I think I've worked slightly smaller than this, but no more than 1 or 2 components. I've soldered fuses. I've soldered fuses smaller than this. However, this is really small we're working at here. Trauma Center DLC. Alright, here comes the hot air. So this gun I'm holding in my left hand is blowing out a stream of hot air at 420 degrees, which is going to melt that solder. And we might need some more flux again in a sec because all my flux is slowly blowing away. Come on, stay straight for me. There we go. Let's just, we'll get the last one on and then we'll straighten those up. Whew. This is going slightly better than I anticipated. I thought the SMD stuff was going to be harder than this. However, thankfully, it's not my first time working on this scale. Okay. Come on. Get on there, bro. Alright, and straighten you up. And you guys all look good. I'm happy with that. That guy's slightly wonky. Let's just make that. There we go. Okay. Right, there's our resistors in place. Now, all of this excess flux, we'll clean this all up when we're finished. However, it's probably not the last time I'll be fluxing the board, so I'm not going to bother cleaning it as we go. Am I sitting on a scale? Kind of. I've got a terrible, terrible seat that squeaks, so I apologise for that. Okay, right, so what's next, my dudes? Oh, there was more to that. Chip resistors to individually welded R1 to R8 What? This guy? Okay. First patch on the back of PCB soldering components to 120 ohms, 121 reads. Chip resistors to individually welded R1 to R8 SMD resistor welding. Right. In the end of the first glue solder pads, then with forceps fixed side, then the other side of the solder can be fixed after the completion of the welding as shown. Okay. This is great. Right, so then R1 to R9 apparently. Okie dokie. This is advancing very quickly, right. Using the same method to 6 SMD transistor welded to the top, R9 20K marked 203, R10 to R14 marked 102. Okay. Okay, I think we can get through this. I think I can get through this. Right, so what's our other guys then? So, what did that say? R9. So where's R10? Right, so using the same method to 6 SMD using 6 method 6 SMD transistor. Okay, let's do those because those are easy enough. So here are our transistors. Here are the twisted transistors, and these are apparently marked 203. So let's check those dudes. Go to super close-up mode. Those are marked 2T1. Right, well those are the transistors. There's nothing else here that could possibly be a transistor. So we're going to stick those transistors on. Okay, so how many of these do we need? We need 6 of them, and we've got 7. So let's weld up our pads. Oh god, I said welding unironically then. That's too much. Decorating town is closed? It's only 7:45. I know they close reasonably early for a takeaway, but good grief. Alright, well yeah, I guess unless you get something, get a ready meal from the co-op or something, Kimbo. Okay, there we go. Right, let's get some flux on there and then we'll just tidy up those little blobs. There we go. The flicks. You're already here and placed an order. Oh, okay. Where are you at, Kimbo? Right, I'm just going to reflow these solder pads I've just done. And then the excess solder will just go onto the iron and I can just remove it. Beautiful. Right, okay, transistor time. Spring rolls I love the idea of, but whenever I actually try them, I'm just like, you're okay. Whoa! Okay, all of my transistors just spilled out, so let's just dump them all in front of me. And we've got a spare one that I'm leaving in the packet. Get off, there we go. Positioning the transistors. The flux is drying out, which is making it go all tacky. Let's just get some heat into there. There we go. Let's flip that boy over because he's upside down. I need him to be the right way up because his legs are pointed in a certain direction. And of course, you don't want your components to be upside down because all the electrons will fall out. And that is my least favourite thing to happen. There we go. Alright. I'm not going to read through that. That looks like a horrible wall of text. Okay, right, okay. We've got the hot air on. Start pushing these guys into place. So I'm not worried about positioning too much yet. We just want to get them vaguely on. And what will happen is, because of the flux, they will naturally flow into place. Because solder wants to flow to metal, and the flux helps that happen. So they'll automatically align themselves onto these pads just under the heat of the hot air gun. And with a little bit of help of the flux. And now we'll just give these guys all a little bit of a nudge. Oh, we got a runaway. We didn't lose him. He went off the board, but we didn't lose him. Get back on there, Slick. There we go. There we go. Transistors, done. Phew. Good. Well, this is going very well. Right, next we've got to do these dudes down here. R9 to R14. Are those actually sequential? 9, 10, 11, 12, 13, 14. Yes, they are. Okay, right, so back to the instructions. Right, R9 is 20K, marked 203. So let's check that. I think these guys look like 203. It's time for poor man's microscope 203. Let's open that dude up. Okay, and let's just tin up R9. Already solder flying around this area, so we don't need to do anything about that. Already flux even, sorry. And here comes the hot air. There we go. Let's make that straight. Beautiful. 203, R9, done. Alright, so then the instructions, R10 to R14, marked 102. Okay, that's these guys, so poor man's microscope. Oh, that's upside down. 102. Oh, some of them are upside down. All my electrons will fall out. I'm gonna get my money's worth out of that joke. Okay, right, so how many of those do we need? 1, 2, 3, 4, 5. And we've got 7 in the packet. Okay, let's tin those pads up before we open the packet. Thanks a lot, Helkith. Yeah, I do a little bit of this for a living when I'm fixing MacBook Pros. When I'm doing liquid damage repair on laptops, we require some very precise work of this ilk. This is the first time I've had to do so much of it on a single place, but this is easy mode. Even though I've got a lot of these components to put on, because this board is very low weight, the soldering is extremely easy. Yeah, I'm making this look extremely easy. If I was doing this on a MacBook Pro, it would be a lot harder because laptops have got very, very heavy circuit boards in them, very high copper weight, and that means they just soak up all of the heat. And you've got to have your hot air on full whack just to melt solder. It's crazy. How are we doing? It's 1954, guys. I can tell from my new watch. Okay. They are. I mean, to be honest, no worse than a Windows laptop, because the good thing about MacBook Pros is because they're expensive and they're worth fixing. Schematics and other technical information is very widely available for them. So, surprisingly enough, it's sometimes easier to fix MacBooks than other laptops just because you can actually find the documentation that you need. Okay, right, let's get our resistors into place. 1. 2. 3, 4. Get off. There we go. And 5. Flip it over. Get off. There we go. Okay, let's get the hot air. Oh, the Mac Mini. Oh, horrible things. I'm not a fan of the Mac Mini. They are a nightmare. The Mac Mini is an absolute nightmare. Not a fan at all. This is nice. I've got my air down nice and low, so none of these guys are trying to blow off the board or anything. Look at you. You're all happy. You can be a little bit straighter. There we go. Beautiful. Nice. Alright. Okay, we're nearly done with the SMD stuff. Oh, bad luck, Helkith. Tell me they've at least put an SSD in it, because otherwise you've got to work with glorious laptop hard drives. Glorious mechanical hard drives. Right. And the base resistance and capacitance oscillator circuit, 30 PF welded on top, complete after as shown in Fig. Alright. Have they put on the capacitors there? I think they've already done their USB port, which is kind of annoying. Oh no, that's fine, we're getting to that. Right, okay, let's stick on the capacitors and the crystal. So the capacitors, these are easy. Oh, actually I lied, there are... What's going on here? I've got too many parts. Is there anything on the back of this board? Yes, there is. Okay. We might need to do a little bit of detective work here. So, hang on a sec. Right, capacitance oscillator current, 30 puff welded on top. So some of these capacitors will be 30 picofarads, and some of them will be different. However, it doesn't tell me which one is which. Where is the other capacitor? C3, clear plastic strip packaging. Okay, we've got clear plastic strip packaging, which apparently is C3. So that means that these guys are C1 and C2. So let's roll back up to that area. C1 and C2, let's do it. So let's tin up our pads. Just started doing a website. Yeah, that's fair. Okay, right. Tinning pads. It's far too much solder on those. We'll get a little bit of... Can I blow some of this flux over? Because we've got loads of spare flux on this board. No, I can't. Fine. More flux. More flux! Okay, let's tidy up those pads. There we go. Okay, right. And let's unpack C1 and C2. Okay, that and that. These guys are not labelled at all. It doesn't matter which way... I mean, none of these components matter in which way up they go. It's just a matter of tidiness. Alright, here comes the hot air. Come on, both ends, please. Thank you. Beautiful. Capacitors done. All right, that. Right, so I'm going to quickly stick C3 on, because once I've put C3 on, that's all of the SMD stuff done, and then we're on to through hole. Oh, we need to do the. Right, yeah, the USB port is SMD as well. That USB port, I wish I'd done that at the beginning. Oh, thankfully, oh, good, I'm very glad. the USB port is going to take a lot more heat than anything else. But thankfully, there's nothing directly on the other side of the board to the USB port. So that means I shouldn't knock everything else astray while I'm soldering that. So let's get the USB port on, because this dude's going to be tough. This one's going to resist. So once again, we're going to tin up these pads. That's too much. There we go. Okay, right, and flux. A loop. Okay, right, now here comes the toughest one. Now we're going to need more air for this one, so I'm going to turn the air up. This guy is probably not going to go on first time round. And I'm actually just going to back the camera out slightly, just so I've got more room to get the hot air on top of it. Where's my focus? There it is. Full air. What the hell is that standing up on? Oh, it's got holes in it. Oh, hang on a sec. Oh, hang on a sec. Abort, 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 abort. Abort. We need to make sure ow! It's really hot. The USB port has got two prongs sticking out of it that I need to make sure are in those holes before I get the hot air on there. So let's make sure that that's lined up properly. There we go. There we go. Now it's ready. Now it's ready. Wow, that's holding on to the heat. Okay. Oof. Right, did we knock anything askew on the back there? Nope, our little dudes are all happy. Okay, right, let's just touch up all those joints with the soldering iron now. Whoops. Okay, that is super, super hot. So we're just going to put the hot air gun on cold and just blow some air across that. There we go. Right, that should calm that down a bit. That's more like it. Okay, right, how strong is that? Yeah, that seems to be on properly. I'm happy. I'm happy that that's strong enough. Right, okay. Right, now that little bit of drama's over, let's put on C3. If I can get the soldering packet open, there we go. Okay, tin up the pads. bit of flux. Don't need much. Just the residue on the end of the syringe will do this time. Okay, right, let's sort out my hot air now. That. Okay. A bit more air than that. Come on, here we go. There we go. Now you see that little elasticity it has there? That's the solder and the flux doing its job. That's why this is not as difficult as it seems, because you can see it's got a little bit of elastic on it just because of the flow of the solder. So it wants to move into place. You just got to nudge it in the right direction. Most annoying thing I've worked on. For me, I mean, my limit is a MacBook Pro display connector, which are on a set. I've got one here. This is the smallest thing that I've successfully soldered. And let me just go into the poor man's microscope so you can actually see the pin pitch here. That's the display connector for a MacBook Pro. And you see how small those pins are. Horrible. My soldering iron is too big, and my solder is too big to work on this properly. And I don't actually have a microscope. So that's the nightmare situation. And again, just for scale, there's the difference in size that we're working with here. So that's nightmare mode. So yeah, I've successfully done one of them once, but it was tough. It took me about 4 attempts. So yeah, I got some mangled ones here where I've pulled them off of the board before. So yeah, horrible job. Horrid. Absolutely horrid. Okay, right. So back to the instructions. We've got to put our oscillating crystal on now. So this, we're onto through-hole stuff now. So I might just clean up the board at this point, because we shouldn't need any more. We shouldn't need any more flux in here, and that means that I can just get the nasty flux out of the way. Flux is carcinogenic. It's horrible stuff. So it's nice to not be dealing with it when you can. Right. Alcohol time. Time for some alcohol. Cleansing alcohol. So this is isopropyl alcohol that I'm spraying onto it. And we'll just clean down that board. I'll sort out that flicker in just a sec, guys. Drops into puddle of flux. Right, let's just get some kitchen roll just to clean that up. George, I will die. Oh no, Mushy, sorry. Do not drink isopropanol. Just the fumes of isopropanol give me a headache if I've been using it in excess. There we go. ESD safe kitchen towels. Anti-static kitchen towels. From Tesco. Cost a quid. Okay, there we go. There's our nicely cleaned up board. Oh, that's not too shabby. They're not perfectly straight, but that's not half bad. Alright. Cheapest assassination ever. Current events. Okay. Right. Frequency crystal. Get in there. Let's just tilt the camera up a bit so it's not looking into its own shadow. Okay, and we're back on the welding iron. Whoop. Oh, that's not on. There we go. Just going to see if I can flatten that down slightly, because we've got a chip going over the top of this. So we need this to sit as flat as possible. There we go, that's better. Okay, right, that's our crystal in place. Right, yeah, well, the oscillator, blah-de-blah, blah, blah. Oh, I was supposed to let the crystal stand up a bit, but whatever. Okay, next USB port, yeah, I've already done that. Boring. Okay, right, next comes our buzzer and our micro. Right, so let's put on the micro first. And then Kimber comes back in with the Tide Pods. Okay, right, here's our micro. There's the half moon indicator, and there's our half moon. So you're going to go in there. Get in. Get in. Get in. Get in. Don't make me bend more legs. Come on. Get in. There we go. And this guy's not going to sit perfectly flat, just simply because we've got the crystal underneath there. All right, so now we've got to solder all around this guy. Let's do it. No. I think we're getting George in. We're bringing in George to help here because this guy's moving about on me. Whack. I might even use both of George's arms and even peer in through the magnifying lens of George's eyes. There we go. Right. There we go. That's a lot of sludge that was on the end of my soldering iron there. That doesn't matter though. There we go. Done. I think you guys talking about breaking legs is probably less friendly than the leg joke was in the first place. Alright, there's our micro. Let's get our buzzer on as well. Now, the buzzer is polarized. Okay, there we go. There's a plus. So, anode is longer. Oh, damn it. Anode goes away from me. Come on. Achoo. Achoo. Get in. Hammer up. Hammer up. There we go. I'll make sure this is flat in a moment. One and two. Hey, there we go. Right. Is my buzzer flat? Miraculously it is. Cool. Let's trim those legs down. Let's put George to one side. Bam. Look at this guy. He's nearly there. Okay. What's next, Mr. Instructions? Blah, blah, blah. C3 is done. Okay, then the two micro switches are welded to the top as shown above. Check all devices have no gaps. Okay. So the two buttons, let's get those in place. Behave, you two. Be nice. Ow! We're having a ball because I'm stabbing myself with tactile switches. More like tactile switches, am I right, George? There we go. Those guys are in. Here's some clicker ASMR for you. Beautiful. Glorious ASMR. Focus and weld. Hey, I said weld. There we go. I'm at all the wrong angle here. Let's turn that around. Better? My light seems like it's flickering, it's annoying me. Around the bottom. There we go. Right, how's that looking? Some focus. Yeah, those are okay. And they are flat on the board. Nice. Alright, I think it's display time. It is. Finally, the digital tube welded on top to complete the correspondence made. Okay. You guys all deserve each other. I'm just gonna say that. You all deserve each other. Okay, right, this is gonna be a pain in the backside because all these pins are not straight. Okay, I think we can manage this. Let's just try getting this all into place. Can I just straighten some of these while I'm at it? That's slightly better than it was before. I think I can get those in now. There's one that's missing. Let's hold it in place while we push that into that hole there. Come on. There we go. Get in. Get in. There we go. Aha! Okay, let's solder them legs in. Get in there. Wagwam. Top peak. Peng. Who is is Jason King the wrestler? Like, I do the E-feds, but I don't actually know anything about wrestling. or is Jason King someone else? Wah. These guys are soaking up quite a lot of solder. Let's clean that soldering iron tip as well. I'm putting sludge everywhere. It's what I get for using archaic solder, I guess, but reflow. That's better. Nice. Okay, and let's trim them pins down and possibly get the camera straight. There we go. Safety glasses. There we go. Ha! Right, that apparently is it. We've run out of components, except for a couple of spares that they gave us. Let's get some power into this bad boy. Let's see what it does. Okay, so there's the USB port on the back. Did it come with a USB cable? No. So let's grab a USB charger thing. Let me see. I need a USB power bank, and I need a USB cable, a micro cable. I've got one kicking around, I've seen it. There it is. And just for kicks, we'll stick a USB ammeter on it so we can see how much power it's drawing. Okay, so power bank, USB ammeter. Right, so here is our 5 volt power supply from a USB power bank. Oh, okay, there we go, it's done. Oh, and the flicker is real on this one as well. Man, I can see that flicker with the naked eye almost. That is a huge amount of flicker. Okay, right, hang on a sec. Let me try dropping to 30 frames a second. Hello, Crazy Unicorn Princess, how's it going? Right, let's see if we can drop to 30 frames for a moment. Can I change my frame rate midstream? No, I can't. Okay, let's risk dropping the camera. Let's go down to 30 frames. Still a lot of flicker. Okay. Let's drop the frame rate big time. Oh boy. That's not helping. What about 5 frames a second? Is that going to fix it? No, although we can really see the flicker there. Look at that. That's almost amazing in itself. Okay. 60 frames again, please. Right. Okay. Right. Well, we can't do anything about the flicker, so you guys are just going to have to deal with that, I'm afraid. So it's so right. It seems that we've got okay. So we have a clock, and it's alternating between hours, minutes, and then seconds. So I'm not sure what these LEDs are doing. There's two of them chasing. Then one of them chasing. No idea what that means. Let's start reading the instructions and see if they tell us anything. Access mini USB cable uses a power supply, blah 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 blah. Oh yeah. Okay. Initialization time is 12 o'clock. You will hear the buzzer sounding cry with digital flicker up and down the grid to remind the whole point of arrival. Okay. That's it. That's the end of the instructions. Okay. We have been building a clock thing. Let's whack up to the top of these instructions. So I think there was a bit more. Right, the front is a digital control PCB. Blah blah blah. Right. Okay. Right. Okay. Function. When and second will automatically switch the display is no longer a monotonous display mode. There is the whole point and the slightest timekeeping function. The whole point of the time up and down the grid full light flashes to remind the buzzer sounding cry. When the slightest square lights up as the buzzer short beeps once. The time period to show distinction. You can also set off the beeper beeps so as not to affect sleep. You can set up automatic daily calibration time. A positive number represents the number of seconds faster, negative number the number of seconds slower. Maximize reduce of the error of time. Press the top button, you can set the time value, setting the time corresponding to the flashing state. Press the following key figures, can be even plus. Well, no nonsense, begin making. Okay. Let's just try. Oh, the buttons are on the wrong side of the board. I put the buttons on the wrong side of the board. No. Okay, it's fine. We can get it with the tweezers. This is fine. Let me get a plastic prying tool so I don't short the whole thing out while trying to set the time. Okay, right. What happens if we push that button then? So, okay, that does nothing on its own. Oh, okay, right. 6 on. Six on. 6 off. Oh, B. That's B. Beep on, beep off. Okay, right, so the beep is now off. We have offed the beep. Let's try holding down the button. There we go. We're now setting the time. So the time... Oh no, my laptop battery is about to die. Hold on a sec. It's time to plug in my laptop. Okay, there we go. Right, the time is 20:31. Hey, Lamau. Okay. And, there we go. $31. Oh, and I don't know how many seconds it is, and I don't particularly care. And beep off. Alright. Well, that's it. I think we did it. Everyone. That is now a clock with a horrifying amount of flicker on it. So, Let me just see what the 30 frame. Let's just check what does the C920 think? Oh, the C920 can't see the flicker. There we go. That's the C920, which is a 30 frames a second camera. That is picking it up just fine. However, I can see the flicker on it with the naked eye, so it's got a horrifying amount of flicker. But yeah, I've no idea what the LED chase thing is actually doing. It seems to just... It's doing something, so, you know, power to him, quite frankly. So yeah. Okie dokie. Oi! Oi! Stop that. Okay, right, that's that. And I think we're done, to be honest. What's our timer on? We're on 2 hours. Right, I think we're gonna call it a day at that. We built so we built two things. We built our weird clock and we built our weird watch.